Take a deep breath, feeling the air fill your lungs before releasing it slowly, and let your body settle into the quiet weight of your mattress. As you drift into this stillness, your mind is beginning a remarkable process of curation, turning the sensory echoes of your day into the lasting architecture of your memory. Isn't it remarkable that within your brain, a small almond-shaped structure called the amygdala is working right now to decide which of today's moments are worth keeping? It acts like a master librarian, using emotional ink to highlight specific memories, ensuring that the warmth of a morning coffee or the soft sound of a loved one's voice is etched more deeply than the color of a passing car. This tiny power player, only about 1 centimeter in length, contains 13 distinct nuclei that coordinate our emotional responses, working in a perfect silent harmony with your hippocampus to index the story of your life. When we talk about how emotions are stored, we are really talking about a physical transformation. To your brain, an emotion isn't just a fleeting feeling. It is a chemical event that changes the very shape of your neurons. This process is known as long-term potentiation, or LTP. When you experience something emotionally resonant, the synapses, the microscopic gaps between your brain cells, which are only about 20 to 40 nanometers wide, actually strengthen. A 2014 study published in the journal Nature demonstrated that the amygdala can physically tag these synapses. It's as if your brain is placing a glowing bookmark on a specific page of your experience, saying, "This matters. Remember the way the sun felt on your skin this afternoon." Think about the sheer scale of this library. Your brain contains roughly 86 billion neurons, and each one can have thousands of synaptic connections, leading to a total of nearly 1,000 trillion synapses. In this very moment, as you relax, your brain is navigating this vast network, deciding which connections to prune and which to fortify. If you were to look closer at these connections, you would see the myelin, the insulating layer of fatty tissue that wraps around the axons of your neurons like a soft white blanket. This white matter increases the speed of electrical signals by up to 100 times, allowing an emotional memory to flash through your consciousness in a fraction of a second. Jeez. Your sensory experiences are the raw materials for these emotional archives. Consider the way a specific scent can suddenly transport you back to a childhood kitchen or a rainy forest path. This happens because your olfactory bulb, which processes smells, has a direct high-speed connection to your limbic system, the emotional center of your brain. Unlike your sense of sight or touch, which must first pass through the thalamus, the brain's relay station, scent goes straight to the amygdala and hippocampus. This is why research from Rockefeller University suggests that we are 100 times more likely to remember something we smell than something we see, hear, or touch. The smell memory is a textured, vibrant thing, stored with a visceral intensity that other senses struggle to match. As you lie here, your brain is also managing its emotional highlighter through a complex dance of neurochemistry. When you experience something joyful, your brain releases dopamine, a neurotransmitter that doesn't just make you feel good. It actually enhances the signal-to-noise ratio in your prefrontal cortex. This makes the memory stickier. A 2011 study at the University of California, Berkeley, found that during the transition into sleep, your brain begins to strip away the emotional sting of the day's events, while preserving the factual information. This is why things often feel much more manageable in the morning. Your brain has spent the night carefully filing the emotion into a long-term storage unit while smoothing out the rough edges of the experience. Even the temperature of your environment plays a role in how your brain processes these emotional traces. Your hypothalamus, a region about the size of an almond, is currently monitoring your internal temperature to ensure it drops by about 1 to 2 degrees Fahrenheit, a necessary prerequisite for deep, restorative sleep. As this cooling occurs, your brain's glymphatic system, discovered only in 2012 by researchers at the University of Rochester, becomes 10 times more active. It literally washes your brain cells in cerebrospinal fluid, clearing out metabolic waste products like beta amyloid. Imagine this as a gentle, cool tide rushing through the crevices of your mind, cleaning the slate so that the emotional memories of tomorrow have a fresh place to land. Your mind is also an expert at tag and capture. This is a fascinating hypothesis in neuroscience which suggests that for a memory to be stored long-term, the brain must synthesize new proteins at the specific synapse that was activated. If you have a mild experience followed by a highly emotional one, the tags created by the first event can capture the proteins created by the second. It's as if a small, quiet candle in your mind is suddenly fueled by a larger flame nearby, allowing a simple moment to become a lasting treasure. This is why we often remember the small details surrounding a big life event. The texture of the chair you were sitting in, or the distant sound of a bell, because the emotional weight of the primary event provided the protein fuel to save the secondary details. Right now, your brain is beginning to produce sleep spindles. These are rapid bursts of rhythmic brain activity, oscillating at 12 to 14 hertz, that last for about half a second. These spindles are like the save button on a computer. They help move memories from the temporary storage of the hippocampus to the permanent hard drive of the cerebral cortex. A 2019 study showed that the more sleep spindles a person produces, the better they are at integrating new emotional information into their existing knowledge base. You might feel a sense of profound peace, knowing that your brain is performing this sophisticated data transfer for you, ensuring your identity and your feelings are safely preserved while you rest. Our minds don't just record experiences like a video camera, they reconstruct them. Every time you recall an emotional memory, you are technically restoring it, a process called reconsolidation. During this phase, the memory becomes labile or flexible again, allowing your current state of calm to infuse into the old memory. By drifting off in such a relaxed state, you are teaching your brain to store your life's story with a foundation of serenity. You are essentially bathing your memories in a chemical environment of GABA, the primary inhibitory neurotransmitter, which acts like a soft hush across your neural circuits, reducing excitability and preparing you for the deep work of the night. Think of the insular cortex, a deep fold of the brain that helps you feel your internal states. It's the part of you that feels the flutter in your chest or the relaxation in your limbs. As you settle deeper into your pillows, the insula is communicating with the anterior cingulate cortex to regulate your emotional tone. This circuit helps you maintain a sense of self that persists from day to day. It's fascinating to realize that your sense of being you is maintained by these physical loops of electricity and chemistry. Even as you lose conscious awareness, these regions continue to pulse with a steady, reassuring rhythm, guarding the engrams, the physical traces of memory that make up your personal history. In the 1940s, the neuroscientist Donald Hebb famously proposed that neurons that fire together wire together. This is the core of our emotional storage system. When you feel a sense of comfort right now, your neurons are firing in a pattern that reinforces the concept of safety. This pattern is being reinforced by the release of oxytocin, you often called the cuddle hormone, which can be triggered simply by the feeling of a soft blanket or the comfort of a heavy duvet. Oxytocin doesn't just promote bonding between people. It also works within the brain to dial down the reactivity of the amygdala, making your internal environment a more hospitable place for the complex work of memory consolidation. Your brain's ability to store emotion is also linked to its incredible capacity for neuroplasticity. Even in adulthood, your brain is not a static object. It is more like a garden that is constantly being reshaped. In the hippocampus, one of the few areas of the brain that can generate new neurons, a process called neurogenesis, roughly 700 new neurons are born every day. These new recruits are particularly sensitive to emotional learning. They are the fresh explorers of your mind, ready to map out the feelings of the days to come. As we continue this journey through the landscape of your mind, consider the sheer efficiency of your biological systems. While you are resting, your brain is using about 20% of your body's total energy, despite only making up about 2% of your body weight. Much of this energy is being funneled into the sodium-potassium pumps that reset your neurons after they fire, ensuring that your emotional library is ready for a new day of recording. The sounds of the room are fading, the texture of the air feels cool and still, and your brain is settling into the rhythmic slow waves of NREM sleep. In this state, your brain is performing a replay of the day's events. Research has shown that the neurons in the hippocampus fire in the exact same sequence they did during the day, but at a speed that is 10 to 20 times faster. It's as if your mind is watching a highlight reel of your life, ensuring every emotional nuance is captured and categorized. You can feel a deep sense of trust in this process. Your mind knows exactly what to do. It knows how to keep what is beautiful, how to learn from what was difficult, and how to rest deeply so that you can experience it all again tomorrow. The architecture of your memory is being built, one quiet synapse at a time, in the soft, velvet dark of your own consciousness. As your breathing slows to a rhythmic, steady pace, the internal architecture of your thoughts begins to reorganize itself. It is compelling to consider that for most of human history, we were entirely unaware of the intricate machinery operating beneath the surface of our awareness. In ancient Greece, around 350 BCE, the philosopher Aristotle posited that the heart was the seat of intelligence and emotion, while the brain served merely as a secondary cooling system for the blood. Imagine the ancient world's view. Our deepest loves and fears were thought to originate in the pulsing heat of our chests, while the mind was seen as a quiet, wet radiator. It wasn't until the physician Galen, in the 2nd century, observed that the brain was the true commander of the senses, a discovery that began a multi-millennial journey toward understanding how you are currently processing the weight of your blankets and the coolness of the air. Picture this. In the year 1564, a Venetian anatomist named Giulio Cesare Arantius was peering into the folds of the human brain when he discovered a structure so distinctive, he named it the hippocampus, the Greek word for seahorse. He noted its elegant curved tail, a shape you still carry within your temporal lobes today. At the time, Arantius could only guess at its purpose, but we now know this seahorse is the vital gateway for your emotional memories. It is the place where the raw, chaotic sensory data of your day, the rough texture of a stone wall, the sharp scent of pine, or the low hum of distant traffic, is transformed into a narrative you can keep. What's happening now is a process that scientists only truly began to map in the mid-20th century. One of the most pivotal moments in this history occurred in 1953 with a patient known in medical literature as HM, or Henry Molaison. After a surgery removed his hippocampus to treat epilepsy, HM lost the ability to form new memories of facts or events, yet he could still learn new physical skills and experience deep emotional shifts. This revelation, led by the pioneering psychologist Brenda Milner, taught us that our minds have different filing cabinets. Your declarative memory for facts is separate from your procedural memory for movements and your emotional memory for feelings. This discovery shifted the entire landscape of psychology, proving that our emotional selves are rooted in distinct physical regions of the brain. Deep within your mind, these regions are communicating with an efficiency that dwarfs any modern technology. While a high-end computer might process data in binary, your brain operates through a staggering network of 1,000 trillion synapses. To put the scale of your internal archive into perspective, a study published in Scientific American suggests the human brain's memory capacity is roughly 2.5 petabytes. If your mind were a digital video recorder, it would have enough storage to hold 3 million hours of high-quality television. That is a continuous loop playing for over 300 years. As you lie in the stillness, your brain is navigating this massive library, deciding which files to keep and which to let go. Notice how some memories feel brighter than others, almost as if they were embossed on your mind. In 1977, researchers Roger Brown and James Kulik coined the term flashbulb memories to describe this phenomenon. They discovered that when we experience a highly emotional event, our brain triggers a unique neural mechanism that captures the moment with startling clarity. Their study found that people could remember their exact location, the clothes they were wearing, and even the weather during significant historical moments, with over 90% vividness, even decades later. However, a follow-up study by Tallarico and Rubin in 2003 revealed a nuance. While these emotional memories feel more accurate, they are actually subject to the same decay as neutral ones. The emotion doesn't necessarily make the memory perfect, but it makes it permanent in our hearts. Consider the physical journey of a feeling. In 1884, the psychologist William James and physician Carl Lang proposed that emotions are actually our brain's interpretation of physical changes in the body. And this James Lang theory suggests that you don't cry because you are sad. Rather, you feel sad because your brain perceives your eyes welling up and your chest tightening. This was later challenged in 1927 by the Cannon-Bard theory, which argued that the emotion and the physical reaction happen simultaneously. Modern neuroscience tells us the truth is a beautiful mixture of both. Your vagus nerve, a long, wandering nerve that connects your brain to your vital organs, is currently acting as a high-speed data cable. About 80% of the fibers in the vagus nerve are afferent, meaning they send information up from your body to your brain. This means the relaxation you feel in your muscles right now is actively sending signals to your brain's emotional centers, telling them it is safe to begin the nightly maintenance of your memory. At this very moment, your brain is also engaging in synaptic pruning. During your childhood, your brain went through a massive clear-out where nearly 50% of your synaptic connections were removed to make the remaining ones more efficient. While this process slows down as we age, it never truly stops. Every night as you rest, your brain is refining its mosaic. Think of your life's experience as a grand mosaic floor. Each day adds new tiles. Some are dull and gray, the routine tasks, while others are vibrant gold or deep blue, the moments of joy or connection. Storing an emotional memory is akin to an ancient scribe illuminating a manuscript with gold leaf. The emotion acts as the gold, highlighting the text so it catches the light of your conscious mind more easily. Deep in the center of your brain, the thalamus is acting as the grand conductor of this symphony. It is roughly the size of a walnut, yet it filters almost all sensory input before sending it to the cortex. As you enter stage 2 sleep, which typically accounts for about 50% of your total sleep time, the thalamus begins to produce those rhythmic electrical bursts we call sleep spindles. These spindles are fascinating. They are the physical manifestation of your brain, moving information from the temporary folder of the hippocampus to the permanent storage of the prefrontal cortex. The prefrontal cortex, which makes up about 10% of your total brain volume, is the most evolved part of your mind. It's the executive that helps you make sense of your emotions, giving them context and meaning. You've likely experienced how a scent can bring back a flood of feelings. And this is because the olfactory system is the only sense with a direct line to the amygdala, which can trigger an emotional response in as little as 20 milliseconds, faster than the blink of an eye. In 2013, a study published in the journal Nature Neuroscience showed that stress hormones like cortisol can act as a sort of cellular glue, cementing these emotional associations into our neural pathways. But here is the comforting part. Your brain also possesses a natural solvent. During the quiet hours of the night, your brain reduces its levels of norepinephrine, a chemical associated with stress. This creates a neurochemically calm environment, allowing you to process the day's events without the accompanying tension. It is also worth noting that your brain is constantly renewing itself. For a long time, scientists believed we were born with all the neurons we would ever have. However, research from the Karolinska Institute has shown that the dentate gyrus, a part of the hippocampus, generates about 1,400 new neurons every day, even into old age. These young neurons are thought to be particularly important for pattern separation, helping you distinguish between similar emotional experiences, so your memories don't become a muddled blur. They ensure that the specific flavor of today is preserved as something unique. As you sink further into the soft embrace of the evening, your brain's white matter is working at peak efficiency. Myelin, the fatty insulation surrounding your axons, can increase the speed of a neural signal from a mere 0.5 meters per second to a staggering 120 meters per second. This ensures that the various parts of your emotional circuit, the amygdala, the hippocampus, and the prefrontal cortex, can stay in perfect sync. While you are dreaming, which we do for about 2 hours every night, these regions are engaging in a collaborative review of your life. History shows us that we have always sought to understand this mystery. From the wax tablet metaphor of the 1800s, where memories were thought to be stamped into the brain, to our modern understanding of neural networks, we are constantly finding new ways to describe the wonder of our own minds. But the physical reality is more beautiful than any metaphor. Your brain is a living, breathing organ of light and chemistry, a 2.5 petabyte archive that is currently being curated with the utmost care. Even your physical state affects this storage. A study found that aerobic exercise can increase the size of the hippocampus by 2% over a year, effectively reversing the natural 1% shrinkage that can occur annually as we age. Your brain is resilient, adaptable, and incredibly dedicated to preserving the essence of who you are. As the boundaries of your conscious thought begin to soften, know that the master weaver of your mind is at the loom, carefully interlacing the threads of your emotions into the fabric of your long-term memory. The temperature of your skin is cooling, your heart rate is finding its steady nighttime cadence, and the vast library of your experience is being tucked away, safe and sound, for the dawn. Each memory is being rebound in the softest leather, each feeling assigned its rightful place in the gallery of your life. As you move toward the deep, restorative silence that your mind has been preparing for all day. Think of your mind right now as a high-functioning digital editing studio, one that never truly closes its doors. While the outer world has grown quiet and the lights are dimmed, the internal editors are just beginning their most important shift. Imagine your hippocampus as a high-speed scanner, rapidly digitizing the Polaroids of your day. This curved ridge of tissue, which resides deep within your temporal lobe, is currently handling a massive influx of data. What's intriguing is that during this specific phase of your rest, the acetylcholine levels, a neurotransmitter vital for focused attention, actually drop by nearly 300% compared to when you are awake. This chemical dip acts like a "do not disturb" sign on the studio door, preventing new, distracting information from entering, so the brain can focus entirely on archiving what you've already experienced. At this very moment, your brain is engaging in a process called spindle ripple coupling. Picture a rhythmic dance between two very different performers. The spindles, those 12 to 14 hertz bursts of activity from your thalamus, are synchronizing perfectly with sharp wave ripples coming from your hippocampus. A 2012 study conducted at the University of California, Berkeley, revealed that this coupling acts like a pneumatic tube system, physically shuttling memory packets from temporary storage in the hippocampus to the more permanent hard drive of the prefrontal cortex. It is as if your mind is moving the files from a cluttered downloads folder into a meticulously organized, triple-backed-up server. Consider the way you might use a highlighter while reading a dense textbook. In your mind, emotion is that neon ink. Scientists discovered that the amygdala sends a signal to the hippocampus to apply extra ink to events that carry emotional weight. This is known as the von Restorff effect, a psychological phenomenon identified in 1933, which suggests that an item that stands out like a sore thumb is more likely to be remembered. If your day was a long gray hallway, an emotional moment is a bright red door. Your brain is naturally programmed to ignore the repetitive texture of the wallpaper and focus its energy on the door. Right now, your neural pathways are prioritizing those bright moments, ensuring that the feelings associated with them are preserved with high-fidelity detail. Deep within the microscopic gaps of your neurons, a physical construction project is underway. For a memory to last, your brain must manufacture specific proteins, such as ARC and BDNF, brain-derived neurotrophic factor. Think of BDNF as a high-grade miracle grow for your brain cells. It encourages the growth of new synaptic connections and strengthens existing ones. During this time of stillness, your brain's protein synthesis increases significantly. It is a literal building process. Your thoughts are being translated into physical structures of carbon, nitrogen, and oxygen. It's captivating to realize that the you who wakes up tomorrow will be physically different from the you who lay down tonight, because your brain will have literally rewired its internal circuitry to accommodate the day's emotional lessons. Notice how your body feels heavy, as if you are gently sinking into the surface beneath you. This physical relaxation is vital because it allows the default mode network, or DMN, to take center stage. The DMN is a large-scale brain network that becomes highly active when we are not focused on the outside world. it consumes about 60 to 80% of the brain's total energy budget, which, overall, is about 20 watts of power, roughly the same as a dim light bulb. While the DMN is active, your brain is simulating different scenarios, relating new emotional data to your past experiences. It's like a grand librarian who doesn't just put a new book on the shelf, but cross-references it with every other book in the building, weaving a more cohesive story of your life. What is happening now is also a form of synaptic scaling. In 2003, researchers Giulio Tononi and Chiara Sorelli proposed the synaptic homeostasis hypothesis. They suggested that during the day, our brains become saturated with new connections, making the neural environment noisy and cluttered. Sleep acts as a necessary downscaling process, where the brain systematically weakens the less important connections by about 15 to 20%. Imagine a gardener who spends the night weeding a flower bed so that the most beautiful blooms, your most meaningful emotional memories, have the space and nutrients they need to thrive. By forgetting the color of the stranger's shoes you passed on the street, your brain makes room to remember the feeling of pride you felt when completing a difficult task. Picture this. Your memories are not stored as single files, but as engrams, or physical traces scattered across different regions. A single emotional memory of a summer picnic might have its visual components in the occipital lobe, its sounds in the temporal lobe, and its feeling in the insular cortex. To retrieve that memory, your brain must refire that specific network. This is where the concept of neural resonance comes in. Like a tuning fork that causes another nearby fork to vibrate, the emotional core of a memory can trigger the entire network to come alive. As you rest, your brain is tuning these forks, ensuring the resonance is clear and the signal is strong. Deep in the brain's basal ganglia, a group of structures involved in habit and emotion, your mind is also processing implicit memories, the ones you don't even realize you have. This is the autopilot of your emotional life. In the 1880s, the psychologist Hermann Ebbinghaus discovered the forgetting curve, which showed that we lose about 50% of new information within the first hour, unless it is reinforced. However, he also noted the spacing effect, which proves that information reviewed over intervals is retained far better. Sleep provides the ultimate space for this interval learning. While you sleep, your brain is effectively quizzing itself on the day's emotional data, moving it from the fragile state of short-term awareness into the durable fortress of long-term storage. Scientists have also discovered a specific protein called Homer 1A that floods the brain during sleep. This protein acts like a master switch that resets the synapses, clearing out the cellular noise. Think of it as a nightly calibration of a high-precision instrument. This reset is why, after a full night's rest, you often find that an emotional problem that seemed insurmountable yesterday now feels manageable. Your brain hasn't just rested, it has chemically rebalanced the scales, reducing the intensity of stress hormones while bolstering the neurotransmitters associated with stability and calm. At this very moment, your brain is also managing its cognitive load. Imagine your conscious mind is a small table, and the world is constantly trying to pile heavy boxes onto it. Sleep is the act of clearing that table and putting the contents into a massive, organized warehouse. In research published in Nature in 2017, showed that during this clearing process, the brain's delta waves, the slow, high-amplitude waves of deep sleep, actually coordinate the movement of cerebrospinal fluid. This fluid pulses through the brain's extracellular space, which expands by up to 60% during sleep, to efficiently transport metabolic refuse away from your neurons. It is a rhythmic, pulsing purification that ensures your neural studio is clean and ready for tomorrow's creative work. Consider the Zeigarnik effect, a psychological finding from 1927, which suggests that our brains are 90% better at remembering uncompleted or interrupted tasks than completed ones. This creates a sort of mental tension. As you move toward deeper sleep, your brain is systematically closing these open loops. It is checking the boxes, filing the reports, and letting go of the tension. It is a profound act of mental housekeeping, allowing you to let go of the to-do list and embrace the is of the present moment. Your brain's storage capacity is truly staggering. If we were to compare it to everyday technology, the 86 billion neurons in your head, each with an average of 7,000 synaptic connections, provide a memory capacity of roughly 2.5 million gigabytes. That is equivalent to recording a continuous high-definition video for 300 years. And yet, this massive system runs on less energy than it takes to power a refrigerator light. It is a masterpiece of biological efficiency, one that is currently working entirely in your favor, preserving your identity and your joys with effortless grace. You notice how the sound of your own heartbeat is a steady, reassuring metronome for this work. Deep in your cerebellum, which contains more than 50% of all the neurons in your brain, your emotional motor memories are being filed. This is why the feeling of how to ride a bike or play an instrument is so resilient. These memories are stored in a way that is almost immune to forgetting. Your brain treats your emotional well-being with that same level of importance, weaving your feelings into the very fabric of your physical self. As you continue this descent into a more profound state of quiescence, your neural pathways are functioning with inherent precision. The master weaver is moving faster now, the shuttle of the loom flying back and forth as the hippocampus and cortex complete their nightly dialogue. When the proteins are being synthesized, the synapses are being scaled, and the emotional highlighter is being tucked away. Your life's story is being bound in a volume that will last a lifetime, stored in a library that is as vast as it is secure. Every breath you take is a signal to this system that all is well, and that the work can continue in the perfect, restorative silence of the night. Consider the way your life story feels to you, not as a dry list of dates and locations, but as a rich, textured narrative where certain moments shimmer with a particular intensity. At this very moment, your mind is acting as a master biographer, deciding which of today's experiences will become a permanent chapter in the book of you. It is compelling to observe that our brains don't just record what happens. They prioritize the meaning behind what happens. This is known as the emotional memory enhancement effect. Studies have shown that we are approximately 40% more likely to remember an event if it was accompanied by a strong emotional pulse. Your amygdala and hippocampus are essentially shaking hands right now, confirming which scenes are vital enough to be archived for the decades to come. As you submerge into the stillness of the evening, your brain enters a unique chemical state that is found at no other time. During rapid eye movement, or REM sleep, which typically makes up about 20 to 25% of your nightly rest, the levels of a chemical called noradrenaline in your brain drop to zero. Noradrenaline is the brain's equivalent of adrenaline. It's associated with stress and high alertness. This is the only time in your entire life when your brain is completely free of this anxiety-triggering molecule. At the same time, your limbic system, the emotional heart of your brain, becomes up to 30% more active than it is when you are wide awake. This creates a perfect, neurochemical laboratory. Your mind can replay the day's emotional events in a safe, calm environment, stripped of the physical sting of stress. This is the foundation of the sleep to forget, sleep to remember hypothesis, proposed by researchers like Matthew Walker at UC Berkeley. Your brain is essentially performing emotional first aid, forgetting the sharp, painful, visceral reaction, while remembering the important lesson or factual detail. It is how you can look back on a difficult moment from years ago and feel the wisdom gained from it without feeling the original racing heart or tight chest. Picture your memory as a magnificent stained glass window in a cathedral. The individual pieces of glass are the facts of your life, the dates, the names, the places. But the emotion is the pigment fired into the glass, and your consciousness is the light shining through it. Without the pigment, the window would just be clear glass. Without the emotion, the memory would have no shape or meaning. During your rest, your brain is firing these pigments, ensuring the colors remain vibrant and the patterns remain clear. Scientists have found that the medial prefrontal cortex, a region just behind your forehead, acts as the curator of this window, integrating these emotional pieces into your self-concept. This area of the brain helps you understand not just what happened, but what it means for who you are. What's happening now is also a shift from verbatim memory to gist memory. This is part of what psychologists call fuzzy trace theory. While a computer records every single pixel of an image, your brain is far more sophisticated. It realizes that you don't need to remember every single word of a conversation or the exact color of every leaf on a tree. Instead, it extracts the gist, the core emotional truth, and the essential meaning. By the time you wake, your brain will have efficiently discarded the noise, the 90% of the day that was mundane, to focus on the 10% that truly mattered. This allows your 86 billion neurons to operate with incredible efficiency, focusing their 20 watts of power on the connections that build your wisdom. It is quite revealing to look at the reminiscence bump, a phenomenon discovered by researchers in the late 1980s. When people over the age of 40 are asked to recall their most vivid memories, they disproportionately remember events from between the ages of 15 and 25. This isn't just because those years were busy. It's because those years were filled with firsts. First loves, first jobs, first major independent decisions. Each of these firsts was accompanied by a surge of dopamine, which acts on the D1 and D5 receptors in your hippocampus to supercharge the memory consolidation process. Your brain recognizes these as high-value data points for your identity. Even now, your brain is using those old foundational memories as a template to help categorize the new feelings you experienced today. There is a beautiful progression in how our minds handle emotion as we age, often called the positivity effect. Research from Stanford University has shown that as we get older, our amygdala actually becomes less reactive to negative stimuli and maintains or increases its reactivity to positive ones. In your emotional library, your brain naturally begins to move the joyful volumes to the front shelves, while the more somber ones are moved to the quiet back corners. This isn't forgetting in a negative sense. It is a sophisticated form of emotional regulation. Your mind is choosing to build your future out of the strongest, most resilient materials. And notice how the weight of your body seems to merge with the bed. This physical state of atonia, the temporary paralysis of your muscles during REM sleep, is a protective measure. It prevents you from acting out your dreams while your brain is doing its intensive emotional processing. While your body is still, your brain's white matter, which makes up about 40% of your brain and consists of millions of miles of myelinated axons, is pulsing with electrical signals. These signals are linking your new emotional memories to older ones, a process called associative integration. Scientists discovered that after a period of sleep, people are 33% more likely to see the big picture or find hidden connections between seemingly unrelated pieces of information. Your mind is literally becoming more creative and insightful while you rest. Deep within the dentate gyrus, a specific fold within the hippocampus, your brain is even now producing new neurons through neurogenesis. These youthful cells are particularly flexible and are thought to be essential for time-stamping your emotional memories. They help you distinguish between a feeling you had this morning and a similar feeling you had 3 years ago. Without this process, your life would feel like a single, overlapping blur. Instead, your mind creates a beautifully organized timeline. Every breath you take provides the oxygen needed for this cellular birth, fueling the ongoing expansion of your internal world. Consider the role of heart rate variability, or HRV. Even as you sleep, when your heart and brain are in a constant dialogue through the vagus nerve. A higher HRV during rest is a sign that your nervous system is flexible and capable of regulating emotions effectively. As you find your rhythm in the quiet of the night, your heart is sending a signal of coherence to your brain's emotional centers. This coherence facilitates the release of brain-derived neurotrophic factor, BDNF, that protein fertilizer we discussed earlier, which helps to physically cement your emotional gains. You are not just sleeping. You are undergoing a profound physical and psychological reinforcement. Deep within your mind, the consolidation to reconsolidation cycle is also at work. Every time you recall a memory, it briefly becomes pliable again, like warm wax. While you are in this state of deep relaxation, your brain can take an old, perhaps slightly tense memory and restore it with a new layer of calm. This is how we heal. This is how we grow. Your brain is a dynamic living system that is constantly refining its own history to make you more resilient for the future. You might think of it as a master jeweler, taking the raw stones of your daily experience and carefully cutting and polishing them until they can be set into the crown of your consciousness. Notice the silence of the room. In this silence, your brain's delta waves, those slow, rhythmic pulses of deep sleep, are dominating your neural landscape. These waves, oscillating at less than 4 Hertz, act like a deep, resonant drumbeat that synchronizes the different parts of your brain. Research suggests that these waves are essential for global systems consolidation, where the gist of your emotional experiences is fully handed over from the hippocampus to the neocortex for long-term storage. This is the moment when a temporary feeling becomes a permanent part of your wisdom. Scientists have also discovered that our self-concept is physically housed in a network of structures called the cortical midline structures. When you think about yourself or your emotions, these areas light up. During your rest, this network stays active, ensuring that your story remains consistent. You are a continuous thread of consciousness, a narrative that remains unbroken even while you sleep. The master weaver is taking the new silk of today's emotions and weaving them into the existing tapestry of your life, ensuring the colors match and the pattern holds. As you continue to move toward the deepest phases of your nightly journey, your mind is performing a silent, beautiful service. It is protecting your joys, learning from your challenges, and constantly updating the map of your world. The architecture of your memory is robust and expertly maintained. The temperature of your skin is perfect, your heart is steady, and your brain is glowing with the quiet energy of its nightly curation. Everything you have felt today is being processed with the utmost care, assigned its place in the vast, light-filled library of your soul as you prepare to cross the threshold into the profound, restorative peace of the late-night hours. It is worth observing that as you remain in this state of quietude, your mind is engaging in a sophisticated sensory review, one that resembles a master perfumer distilling the essence of 1,000 flowers into a single potent vial. This distillation of your day is what allows an emotion to transition from a fleeting sensation into a permanent part of your history. Science reveals that your brain's ability to store these memories is deeply tied to the specific environmental cues present when the memory was first formed. For example, a landmark 2007 study at the University of Lübeck demonstrated that the sense of smell is a powerful catalyst for memory consolidation during sleep. Researchers exposed participants to the scent of roses while they learned a task. When that same scent was released into the room during the participants' slow-wave sleep, their memory retention improved by over 15%. This happens because the olfactory bulb has a nearly direct pathway to the hippocampus, bypassing the usual sensory filters. Right now, even the faint familiar scents of your own room are providing a stable sensory anchor that helps your brain categorize the day's events. What is occurring at this moment is a symphony of sensory gating. Your thalamus, the brain's grand central station, is currently acting as a sophisticated soundproofing system. It produces bursts of electrical activity that prevent external sounds, like a distant car or the hum of a fan, from reaching your conscious awareness. This allows your internal world to become vibrant and focused. Within this focus, your brain is processing the hedonic value of your experiences, a task managed by the orbitofrontal cortex, located just above your eyes. This region evaluates how pleasurable or significant a moment was, essentially color coding your memories. A sunset isn't just stored as a visual data point. It is tagged with the warm golden hues of the specific joy you felt, ensuring that when you recall it years from now, that same emotional temperature will resurface. Deep within the microscopic landscape of your mind, the chemical adenosine is being systematically recycled. Throughout the day, as your 86 billion neurons fired, they produced adenosine as a byproduct, creating what scientists call sleep pressure. By this hour, the adenosine levels in your brain have reached their peak, binding to receptors that tell your system it is time to transition into the deep, restorative maintenance of your memory archives. As you rest, this pressure is slowly released, a process that is as essential for your mind as physical cleaning is for a workspace. While this clearing occurs, the pineal gland, a small pine cone-shaped structure in the center of your brain, is releasing melatonin. Beyond simply helping you feel drowsy, melatonin acts as a powerful antioxidant, protecting your neurons from oxidative stress and ensuring the delicate engrams of your emotional memories are not damaged by cellular wear and tear. Picture the way your mind handles color and light while you are in the quiet of the night. Even with your eyes closed, your visual cortex remains remarkably active. Specifically, Area V4 of the visual cortex, which is responsible for processing color, can fire during your dreams as if you were looking at a vibrant painting. This is why our emotional memories often feel saturated with color. In a study published in the journal Frontiers in Psychology, it was found that approximately 80% of people under the age of 30 dream in rich, vivid color, a number that has actually increased since the advent of color television. Your brain is a chromatic archive, using these internal pigments to make your emotional history feel as real and textured as the world outside. Consider the temperature of your thoughts. Scientists have discovered that for the brain to consolidate memories effectively, its internal temperature must drop. This cooling is regulated by the preoptic area of the hypothalamus, which contains roughly 100,000 temperature-sensitive neurons. This thermal downregulation reduces the metabolic rate of your brain, allowing the energy to be shifted away from active thinking and toward the LTP, long-term potentiation, we discussed earlier. It is in this cooler, quieter state that the theta waves, oscillating between 4 and 8 Hz, become prominent in your hippocampus. These waves act like a rhythmic pulse, a neural hum that coordinates the timing of when neurons fire. This timing is critical. If 2 neurons fire within 20 milliseconds of each other, the connection between them strengthens. This is the physical birth of a memory, a spark of electricity in the cool dark of your mind. The science of emotional tagging is even more intricate than we once thought. When you experience something emotionally charged, your brain releases plasticity-related proteins, or PRPs. These proteins act like a physical glue at the synapse. A fascinating 2011 study at the University of Edinburgh found that these proteins can stay active for several hours, waiting for a memory tag to arrive. This explains why we often remember the mundane events that happened right before a big emotional moment. The PRPs were already present in the synaptic neighborhood, allowing the quiet moments to be caught by the emotional storm. At this very moment, your brain is checking all the neighborhoods of your day, making sure every tagged moment has been properly glued into your permanent record. Notice how the boundaries of your body feel less distinct as you move toward deeper sleep. This is partly due to the activity in the precuneus, a part of the parietal lobe involved in self-consciousness and spatial awareness. During sleep, the activity in the precuneus changes, in shifting your focus from the external self to the internal narrative. While your external senses are dampened, your interoception, your ability to feel the internal state of your body, remains vital. Your brain is monitoring your heart rate, which should ideally drop by about 10 to 20% during deep sleep. This synchronization between the heart and the brain is known as cardiovascular neural coupling. A steady, slow heart rate provides a stable foundation for the gamma oscillations, 30 to 100 Hz, that bind different sensory aspects of a memory together into a single cohesive experience. What's happening now is also a fascinating process called synaptic scaling, or the downscaling of the brain. During the day, your brain creates trillions of new connections. If this continued unchecked, your neural circuits would become overloaded, much like a power grid during a heat wave. To prevent this, your brain systematically weakens the noisy connections while preserving the strong, emotional ones. Research from the University of Wisconsin-Madison has shown that during sleep, the size of your synapses actually shrinks by about 20%. This pruning ensures that the most important emotional signals remain loud and clear, while the background hiss of the day's trivialities is silenced. It is a nightly retuning of your internal radio station, ensuring you wake up with a clear signal. Deep within the pons, a part of the brainstem, a cluster of neurons is currently sending signals to inhibit your spinal cord, creating the atonia, or muscle relaxation, that keeps you still. While your muscles are quiet, the pontine geniculate occipital, or PGO waves, are triggering the vivid sensory experiences of your dreams. These waves move from the brainstem to the visual centers, creating internal sight and sound without any external input. During this time, your amygdala's activity can increase by up to 30%. This high-intensity emotional processing is why dreams can feel so visceral. However, because the prefrontal cortex, the part of the brain responsible for logic, is less active, these emotional replays can take on a surreal creative quality. Your brain is essentially stress testing your emotional resilience in a virtual reality environment where there are no real-world consequences. And scientists have also discovered that the glymphatic system, the brain's self-cleaning mechanism, is most active when the brain is in its most relaxed state. This system is driven by astrocytes, star-shaped glial cells that surround your neurons. During sleep, these cells actually shrink in size, increasing the extracellular space between neurons by up to 60%. This allows the cerebrospinal fluid to flow 10 times faster through the brain, flushing away metabolic debris like tau proteins. Think of it as a clear, cool mountain stream rushing through a forest, cleaning every leaf and stone. This ensures that the soil of your mind is fertile and healthy for the new emotional seeds of tomorrow. It is worth observing that your self-narrative is physically anchored in the medial prefrontal cortex, when this region works with the temporal poles to store semantic memories, the facts about your life. But it's the parietal cortex that handles the memory of objects and their emotional familiarity. When you think of a cherished possession, the parietal cortex is what gives you that warm, "I know this" feeling. During your rest, these regions are working in a distributed network, ensuring that your memories of things are correctly linked to your memories of feelings. Your life is not just a collection of events. It is a rich tapestry of associations, where the texture of a sweater can be inextricably linked to the warmth of a conversation. As the air in the room feels cool against your skin, and the weight of your blankets provides a steady, grounding pressure, your brain is finishing its most intensive sensory audit. Every sound you heard today, every texture you felt, and every scent you encountered has been reviewed. The master weaver is moving toward the final stages of tonight's work, securing the last few threads of the day's emotional story. The chemicals are balanced, the synapses are scaled, and the neural studio is clean. You are moving toward a state of profound, undisturbed integration, where the you of today becomes the you of forever. The rhythmic pulsing of your brain waves is slow and steady now, a deep, resonant bass note that signals the completion of the day's curriculum. Your mind is ready to surrender the last of its wakeful thoughts, knowing that every precious emotional detail has been safely tucked into the light-filled library of your soul. In what you are experiencing now is the final elegant sequence of the mind's nightly curriculum. At this stage of the evening, the sun has long since set, and your internal biological clock, a cluster of 20,000 neurons, known as the suprachiasmatic nucleus, has sent its final chemical signals to the pineal gland. This process initiated the release of melatonin, which has now reached its peak concentration in your bloodstream, acting as a master key that unlocks the door to deep, restorative states. As you lie here, your brain is transitioning from the high-frequency activity of wakefulness into the slow, rhythmic pulses of the late-night hours. It is a step-by-step handover of power, where the conscious ego recedes and the biological maintenance systems take full command of your identity. Step 1 of this descent began as your brain waves shifted from alpha, the 8 to 13 hertz frequency of relaxed alertness, into the theta waves of stage 1 sleep. During this transition, which typically lasts only about 1 to 7 minutes, the ventrolateral preoptic nucleus, or VLPO, began releasing inhibitory neurotransmitters like GABA and galanin. These chemicals act like a soft, heavy curtain being drawn across your arousal centers, such as the tuberomammillary nucleus. At this very moment, your heart rate has likely slowed by 10 to 15%, and your core body temperature has dropped by nearly a full degree Celsius. This cooling is a prerequisite for the most intense phase of memory storage, as it allows the brain to divert its 20-watt energy supply away from temperature regulation and toward the physical synthesis of new proteins. Notice the sensation of absolute stillness. You have moved into stage 2 sleep, which occupies approximately 50% of your total rest time. Within this phase, your brain produces K-complexes, which are the largest electrical events in the healthy human brain. These singular, high-amplitude waves last for about half a second and serve as a protective barrier, suppressing external sensory interruptions to ensure your emotional processing remains undisturbed. Following each K-complex, your thalamus generates a rapid-fire burst of sleep spindles. A 2012 study published in the journal Neuron demonstrated that these spindles are the physical mechanism that shuttles emotional data from the short-term buffer of the hippocampus into the permanent archive of the neocortex. It is a meticulously timed courier service, moving the essence of your experiences into the durable architecture of your long-term self. As the night deepens, you enter stage 3, also known as slow-wave sleep, or N3. This is the most profound state of restoration, where your brain waves slow to a majestic 0.5 to 2 hertz. In this state, the global system's consolidation reaches its peak. Scientists discovered that during these slow oscillations, the memory engrams, the physical traces of your emotions, are replayed in the hippocampus at a speed 10 to 20 times faster than they occurred in real life. This compressed replay is essential. It strengthens the synaptic connections by a process called long-term potentiation. Research from the University of Lübeck suggests that this nightly replay is so efficient that it can improve your recall of emotional information by 20 to 40% compared to staying awake for the same duration. Deep within your neural pathways, a physical construction project is reaching its conclusion. For an emotional memory to stay with you for a lifetime, the brain must engage in protein synthesis. Molecules such as ARC and Homer 1A are currently flooding your synapses, acting as the mortar between the bricks of your memories. This process is most active during the first half of the night, when your growth hormone, somatotropin, is released in a massive surge. In fact, nearly 80% of your daily growth hormone is secreted while you are in this deep, slow-wave state. This hormone doesn't just repair your muscles, it facilitates the neuroplasticity that allows your mind to grow wiser from the day's emotional lessons. What's happening now is a profound neurochemical reset. As you surrender to the rhythm of your breath, the levels of cortisol, the primary stress hormone, have dropped to their lowest point in the 24-hour cycle. This creates a low-stress window that allows the prefrontal cortex to communicate more effectively with the amygdala. A 2011 study at UC Berkeley found that a night of sleep actually recalibrates the amygdala, making it 60% less reactive to negative stimuli the following day. Your brain is essentially performing a sophisticated emotional leveling, ensuring that the frustrations of today do not overflow into the potential of tomorrow. You are being scrubbed clean of tension at a molecular level. Consider the glymphatic flow that is currently moving through your mind. As your brain cells shrink by up to 60% during deep sleep, the space between them, the interstitial space, expands, allowing cerebrospinal fluid to pulse through the tissue. This fluid is carrying away metabolic debris, such as the protein fragments known as beta amyloid, at a rate 10 times faster than when you are awake. Picture this as a clear, cool tide that rises every night, refreshing the delicate landscape of your neurons and ensuring that the emotional highlighter we've discussed has a clean white page to write upon. This purification is why, upon waking, your thoughts feel crisp and your perspective feels renewed. We are now moving toward the late-night cycles of rapid eye movement, or REM sleep. In this phase, your brain's metabolic rate actually increases, sometimes becoming higher than when you are focused on a complex task during the day. However, your brainstem is simultaneously releasing glycine and GABA to paralyze your motor neurons, ensuring your body remains in a state of atonia, or complete relaxation. While your limbs are heavy and still, your anterior cingulate cortex is highly active, weaving the day's emotional threads into a distributed network. This is why REM sleep is so closely linked to creative problem solving. A 2009 study found that people who reached REM sleep were 40% better at solving puzzles that required outside-the-box thinking. Your mind is making associations that your conscious self would never consider, linking a new feeling to a memory from a decade ago to find a deeper meaning. Notice the steady, slow beat of your heart, which has now found its nighttime coherence. The autonomic nervous system has shifted its balance entirely toward the parasympathetic branch, the rest and digest system. This shift allows for the retroactive interference reduction, a phenomenon where sleep protects newly formed memories from being overwritten by new information. By resting now, you are essentially locking the file on your day's achievements. You've experienced this before, the way a difficult skill or a complex emotion suddenly clicks after a good night's sleep. This is the result of your 86 billion neurons completing their nightly collaborative review. At this very moment, your self-concept is being updated. The medial prefrontal cortex is integrating the gist of your day into your long-term identity. This region ensures that the story of you remains a continuous, unbroken thread. Even as your conscious awareness fades, your brain is guarding the engrams of your joy, your connections, and your peace. You can trust this process implicitly. It is a biological certainty, as reliable as the tides and as ancient as life itself. Your mind is designed to heal, to store, and to protect. As we approach the final moments of this journey, your brain is preparing for the deep maintenance phase that will continue for the next several hours. The adenosine that built up throughout the day has been almost entirely cleared, and the synaptic scaling has ensured that your neural grid is efficient and balanced. The proteins are set, the synapses are pruned, and the emotional archives are locked in their secure, light-filled vaults. You have nothing left to do but exist in this state of perfect, restorative silence. Your mind is a wonder of biological engineering, a 2.5 petabyte library that is currently being curated with infinite care. Every breath you take is a confirmation of safety. Every slow wave of your brain is a pulse of restoration. You are moving into the quietest part of the night, where the work of the day is done, and the wisdom of the future is being forged, and the textures of your world are soft, The air is cool and still, and your heart is a steady, reassuring drum. Your brain is doing exactly what it was evolved to do, turning the fleeting moments of your life into the permanent treasure of your soul. You are safe, you are held, and you are being renewed at the most fundamental level of your being. The master weaver is finishing the final knots in the tapestry of today, and the loom is slowing to a gentle, quiet hum. I am confident in your mind's ability to carry you through the rest of this night. The library is quiet. The lights are low. The story of today is safely stored. My mind is quiet and calm. My memories are stored with care. My brain is healing while I rest. I am safe in the stillness of the night. My identity is preserved and protected. I am ready for the restoration of deep sleep. The journey through the mind is complete for tonight. The chemistry is balanced, the neurons are synchronized, and the descent is total. Good night.